So if you're a follower of my channel, you probably have noticed that I've got a little bit of an obsession with low power design, to the point that I actually went out and designed my own board here called the trigBoard, which is an ultra low power platform for the ESP8266 Wi-Fi module. Well, I made this board available on my Tindy store and sold out, and they've been sold out for a couple months now. So what have I been doing? Well, let me introduce you to the trigBoard V8, which is better in every way than the trigBoard V7. So in this video, I'm going to go through the entire design and show you exactly what this bad boy can do. But just before we get into all of the new features of the trigBoard V8, I've got a very simple example set up here where we're powering the board from two AAA batteries and we're monitoring some kind of door here. And what we want is when this door opens, we get a push notification on our smartphone within 5 seconds. And there you see it there. But what's cool is we also have a timer running that is configurable so that now when the door is left open, contact's still open, and then we can shut the door, and then the same kind of thing, within 5 seconds the contact has closed. So that's a very basic example of what you can do with the trigBoard, and all of that is configurable, and that's what I'm going to show you in this video, all of those configurations and how you can modify a simple example like this to do anything you want. So let's go ahead and get into it. So all of the new features for the trigBoard V8 actually were driven by you guys. All of those comments from the previous trigBoards I've designed and all of those YouTube videos I took into consideration for the new V8 board, starting with updating it to the ESP32, which is why it is slightly bigger than the V7 board with the ESP8266. And upgrading it to the ESP32 was a great idea because now we've got tons more I/O, we have more program space, we also have a better Wi-Fi chipset, and of course Bluetooth, which you'll see how I use that in a second here. And what to do with all of that extra I/O? Well, I broke it all out here to through-hole pins, which was another suggestion. Instead of having the pads, the surface mount pads here along the side, many of you suggested to use through-hole pads or through holes like this and make it breadboard compatible. So this, when you solder on the headers, you can plug it straight into a breadboard for easy development. So here you can see on the wiki, we've got all of those pins labeled there and what they do. And I noticed many comments requesting support for a wider input voltage range. So now, of course, like you saw in that little example here, I can support two AAA batteries, 3 volts, or really anything from 1.8 volts to 5 volts. So you're no longer limited to just a 4.2 volt lithium cell. In fact, in my Tindy store, I'm making these little AAA battery holders available as an option with the trigBoard V8. So that's kind of cool. And I would recommend using the Energizer Ultimate Lithium batteries for this because you'll get amazing battery life using those. Of course, you can still use a lithium battery if you want to. It's up to you. And another fun feature that I added in was based on a few emails I received from people after sending them the trigBoard V7. They said their trigBoard would not wake up. So I asked them to send me a picture of their battery, and sure enough, many times it was because the battery had the wrong polarity and that was blowing up the board. So now with trigBoard V8, we have reverse polarity protection built in on the battery input. So that's pretty cool. And you might remember on the trigBoard V7, it could only wake up on the contact closure or contact opening, not both at the same time. And if you wanted to monitor the contact on the timer wake, you had to make a little modification to the board. Well, all of that's gone. Now on the trigBoard V8, it's all completely configurable in software. You can wake on the contact open, the contact close, or either you can monitor the contact status on a timer wake, and that timer is configurable. So just right there was a lot of hardware put in to support that. So we now have an actual high-quality real-time clock on the board that is configurable in software, so you can wake up at whatever interval you want to check the contact. And that's great for, that garage door type example where you want to know when the garage door opens, and then after, an hour, you want to be notified that somebody left the garage door open. And also, you can get a push notification when the garage then closes again. So you've got all of that flexibility now built into the trigBoard. And just a quick side note, I've got new accessories added in on the Tindy page for the trigBoard, so you no longer have to go and source all of these different things out yourself. You can just go and select the contact sensor, the battery holder. You can even get a USB to serial converter so that you can reprogram the trigBoard if you want to. And one of the fun ones that I added in there was a little 3D printed enclosure. And this was my own design. I'm not a mechanical engineer, so don't judge. But this is cool because it lets you slide in your trigBoard like that. And then the battery holder just fits right in there. You can plug it right in. And then all your wires just bunch right in there, just like that. And the whole thing just snaps together just like that. And then you've got your sensor there. So kind of a fun thing, but I'll make this these files available for download so you can take it, make your own enclosure. I've got a full 3D model of the trigBoard too, so you can create your own enclosure for this. I'm sure you can do a much better job than me. But anyway, I just wanted to point that out, that now there are accessory add-ons with the trigBoard. So all of these new features would be meaningless if I wasn't still able to maintain that ultra low sleep current while it's just sitting there like this. And when I say that, not only while the magnet is keeping the contact closed, but also when the magnet is far away and the contact is open. So in both states, which is important because if the door is left open, we don't want a pull up or pull down resistor or whatever pulling current from the battery. So in both states, we need to maintain that ultra low sleep current. And with my new toy here, we've got the OT Arc powering the trigBoard. We're powering it at 4 volts, and you can see our average current is 1.06 microamps. So it's still insanely low. Oh, and just for fun, I thought it'd be cool to compare this to like a smoke detector. So I actually had one, I pulled it out and hooked 9 volts up to it, and that pulled about 7 microamps. So just for reference, the trigBoard pulls less current than a smoke detector. Then of course, when we wake the trigBoard up, we're going to see a big spike in that current. It wakes up, connects to the Wi-Fi, there's my push notification, and goes back to sleep. Now, this is kind of cool. If we look right here, you see that it was able to boot up, connect to the Wi-Fi network, get the push notification out, and go back to sleep all within about 2.5 seconds. So I didn't realize that the ESP32 has way better performance than the ESP8266 from not just the boot up, but also getting connected to a Wi-Fi network. So it was kind of a cool thing there. Now I did mention that the trigBoard V8 contains a booster. So we're actually boosting voltage up, and that allows you to have a wider range of input voltage to the board. So now if we power it from, let's say, 2 volts, what does that do to the current? So here we are with the same exact setup, except now that we're powered here with 2 volts. And you can see the average current is 2.2 microamps. So still insanely low. And of course, when we wake it up, you see it wakes up, gets connected to the Wi-Fi network and gets that push notification out. And that was about 4 seconds that time. So a little bit longer there. But then I forgot to show you that it also maintains the low current even when the contact is open. So let's take a look at that with the 2 volt input. It's actually a little bit lower. You see our average current is 1.7 microamps. So it's actually lower with the contact open, not by much though, you're just talking about 1 microamp there. But I'm really thinking that the sweet spot for the trigBoard V8 is to power it with 2 Energizer ultimate lithium batteries, AAA batteries, and with that you'd have your 3-volt input, and you can see the average current there is 1.3 microamps, so pretty darn good. Now let's get into the configuration, because I put a lot of time into how you configure the trigBoard V8. So if you go to the wiki page for the new trigBoard V8 and you scroll all the way down to the out-of-the-box setup, you'll notice here that I've got something called the configurator. And this is very cool. So this is how you set up the trigBoard. Now previously with the trigBoard V7, it was done using the Wi-Fi manager library, where it set itself up as an access point and you connect to it, and then it launches a little captive portal that you type in everything. Your Wi-Fi SSID and password and your push safer credentials. Well, that was cool and all, but I've had problems with that. It was just a little clumsy, and I hated disconnecting from my previous internet connection, and if I had an Ethernet cable plugged in, sometimes it would default to that, and it was just kind of messy. With this, we're actually going to connect to it using Bluetooth. So to do this, we're going to launch my app here. I created it in Google Chrome, and this needs to be run on Google Chrome from your Windows 10 computer or Mac, Mac OS, Linux. It may run on Android, but I know for sure at this point it does not run on iOS. I'm working on something that will support it in iOS in the future. It also makes sure that it's HTTPS when you go and click this link. It may default to just HTTP, so make sure you've got the S in there. And you'll know you have it working because when you go to this, you'll see the little lock symbol, and when you click connect, this little window pops up. So you know that you're actually trying to connect to something. And this was written using P5JS with the P5BLE plugin, which I've made videos on in the past. So what we do is press and hold the wake button. You'll see the LED turns on there. And if you have it previously set up with some credentials, you will also get a push notification on the phone saying that the button was pressed. Then you can let go when the LED starts flashing. Alright, now you ready for the coolest part of this trigBoard? Here we go. Click connect. You'll see the trigBoard there. We're going to pair up with it. And there you have it. We're connected to the trigBoard V8. So there's a lot going on here. I'm going to go through this line by line so that it all makes sense. It's very easy. So the top part here is just showing you the status of your trigBoard. So you see the firmware version, the MAC ID of the trigBoard, if it's connected to a Wi-Fi network, and the IP address it's given. You also have your blinky LED here, which is kind of cool. I've animated. You have the status of your contacts. So you see here it's closed. I'll open it up, and there it goes to open. So you can test your full system. You see the battery voltage readout. We can even press the wake button and it'll light up for us, which is cool. So you're actually going to type in the SSID you want it to use. I could have put like a little scan screen in here and all that, but it's almost easier if you just type it in. And then your password, and then you can test it out by clicking save and connect with DHCP. So you see it goes disconnected and then reconnects. If you wanted to, you could have a static IP. So you click this checkbox, hit save, and now we can give it a static IP. And set this up however which way you want. We can click save and connect with static IP. And then now we have got a static IP. Just as simple as that. Now why might you want to use a static IP? Well, if you're on a network where you don't want to use DHCP because it's slow, maybe you want to speed things up. On my setup here, I have not seen any speed increases by going to static IP, but I put it in there as an option. So I'm going to uncheck that, click save, save and connect with DHCP, and we're back on the DHCP IP address there. Alright, I forgot to zoom in on this stuff, so hopefully you could see that, but now I'll keep it nice and zoomed in for you. Okay, so here's something that I ran into a lot on V7. So people would tell me like, oh, I got a really old router, and so I had it set to 5 seconds in the firmware to connect, to an access point and then just give up. If it doesn't connect within 5 seconds, just die. So I added in this. So now you can set this to whatever you want. You can set it to 10 seconds if you wanted to. You could set it to anything you want, all the way up to 60 seconds. Probably not a good idea to set this too high because it's going to hurt your battery life if it is continuously failing to get on a Wi-Fi network. So you should really try to figure out why it's failing. If it's too far away, put it in an extender in of some kind, or figure something else out. And I'll show you a couple things that you can do on that too. Okay, the trigBoard name is important because that's what shows up here in your push notifications. You see front door, so you put that to anything you want. And then the next one is wake on, open and close. So in this case, I'm actually waking it up when the contact opens and closes. And then you can set the message that you want that to be. Now keep in mind that you need to hit save after each and every one of these. So like if you go and do that, and then you do this, and you do this, and then you hit save, watch what happens. That unchecks because you didn't hit save here. Okay? So wake on, open and close. You can choose just open if you want, and then you're only going to have it wake up when contact opens up, or contact closed, or both. And you see here I had that contact has closed, so you can see the format of the push notification. Also, you can customize what you want the message to be when the button is pressed. And why would that even matter? Well, you could actually attach 2 wires across the button for something else you might want to add to wake up the system. So just threw that in there. Alright, now we can talk about the timer. So this is very cool. So you've got your timer units, and this is when the contact opens, this timer will start counting. Okay, so you notice when I opened that contact up, then 10 seconds later I got the push notification. So that's the way the timer works. Now the timer's always going. So even when it's just sitting there, it's going to be counting down. And the reason for that is it's a safety check, so that, you know, what if the battery dies on your door? You would never know. So what this does is you would set this timer up, and it's going to, on this interval, in this case here, 60 minutes, every 60 minutes it's going to check to see if the battery is low, and if it is, send a push notification out. Otherwise, just go back to sleep. And you've got a lot of options here with the timer. So you've got minutes, so it can be all the way up to 255 minutes, which I think is like 4 hours and something, or even seconds. So you could do it like a 10-second timer like I did. Now this is going to smoke your battery because the timer wakes up every 10 seconds in that case regardless. It's not on for very long, but it's a good idea to keep this as long as possible. So like, for the garage door, maybe 30 minutes you might want to set it to, or 15 minutes, but not 10 seconds or whatever. So I put it in there as an option for you, but it's probably not a good idea to go too fast with that. So I'll set that back to minutes, 60 minutes, hit save on that. Timer checks for low battery, and then this is where you can configure that timer to do other things. So like nothing would just be, it's only checking for a low battery. And here is the low battery threshold. But in that example with the garage door opener, you may want to also check if it's still open. So you would set that to still open, and then here you have your message you can set that to, like left open or whatever, because you're still going to get the name here. So front door left open, or front door, whatever. You can set this to any message you want in there. And keep in mind, this is all development code right now, so, there's not a whole lot of error checking. So, be careful by using like special characters. Like, don't use like the pound symbol, or don't use any symbols actually. So, and also keep your messages short. Don't go any beyond anything really that you see here. If you have some crazy long thing, it's gonna be out of bounds for one of the arrays down at the trigBoard. And also, by the way, the timer can wake on both, or check for both anyway. So if it's waking up, it can tell you always what the status is. So you can see status front door is opened still, or whatever, and then this would be has opened, so, or is open, I should say. So you could get a continuous update on whatever it is every 60 minutes in this case. Alright, we already talked about the low battery threshold, and now we get into the credentials, or the push notification service section here. So we've now support a lot of different things. So now it also supports Pushover, which is a kind of a cool service, and that's what I'm using here on my phone. But just because I know a lot of people were still using Pushover from the last board, I still have that in here, so you can open that up, put your key in, and if you go back to the wiki page, I've got little examples here on how to set that stuff up and how to get these keys. And you can go in and compare the differences between Pushover and Pushover, but you know, really what I like about Pushover for this is that you buy the app once for like $5 at the time of making this video, and they give you like 7,000 pushes a month or something. It's a really good deal. Whereas with Pushover, you're paying per push, which are also very cheap, but you just buy like a block of 10,000 pushes, and then, you know, you have to replenish it every once in a while. So they're both very good, and they both have some pretty cool features, so you might want to go in, compare the two, and you could use both if you wanted here. So when you have multiple checkboxes here set up, you're going to get your Pushover, then you're going to get your Pushover, and then so on. So that's also kind of a nice thing, and I'll make the firmware available for this base firmware so that you can tweak it if you want. So you could actually set it up however which way you want. And I also added in support for if this then that. And if you don't know anything about this, you should go check it out because you can do a lot with this. This basically ties the trigBoard into the internet. I mean, anything you can possibly think of, you can do. You could do the push notification straight from if this then that and create a recipe for that so that it sends out notifications. They're a little slower though on if this then that. But you could also populate a Google Sheet. So you can create some kind of data logger. You could send out emails. You could send out a text message. You could turn the lights on in your house or off, you know, so you can tie it into a lot of other home automation systems, which is pretty sweet. And I'll probably make a whole video on some of these things, but for now I'm just putting it in there. All you need is your maker key, and again, go back to the wiki and you'll see how to do that. But, you know, all of these things require that the trigBoard connects to a Wi-Fi network that has internet access. But what if you're monitoring some kind of remote location that does not have Wi-Fi or internet access, I should say? Well, for that, I used to use ESP-NOW on the trigBoard V7 for that, where all of the trigBoards would connect back to a base station that would bridge over to so it would have a trigBoard there as well, or some kind of ESP8266, collect those messages, and then send them out via cellular out so that you can monitor them anywhere in the world. And that's the way that worked, but with the ESP32, I wasn't having a whole lot of luck with ESP-NOW, so I decided to use UDP messaging. So basically the way this would work is you've got another trigBoard or another ESP32 serving as the gateway. And it could be an access point to all of your other trigBoards, or it could be on another network with no internet access. And then basically when the trigBoard wakes up, it sends a UDP packet out on that Wi-Fi network to be received by the gateway. Now this is very cool because you put in the SSID. I'll actually set it up right here. Yeah, so let me give you a quick demo here. So I've got another ESP32. This is just a little Adafruit ESP32 featherboard, and it's running some gateway code that I put together, and I'll make that available as well. And it is acting as an access point here. So it's got its own network, hidden network, which is kind of cool too. So if you wanted this whole thing to be somewhat secure, it's not an available network that you can see when you go and look at all the Wi-Fi networks in your area. And it's actually named your UDP SSID, and I did this for testing reasons, which I'll get into probably in another video. So anyway, what this will do though is you set this whole thing up. Okay, we're going to give this trigBoard a static IP 4.2 there. And then its target IP will be what this one is, 4.1, and I'll probably make a separate video on this as well. But down here, which is cool, is a blast count. So to guarantee the UDP message gets out, it'll send 10 messages right in a row at an interval of 10 milliseconds. So it'll send one, wait 10 milliseconds, send the next one, and so on. So I'm going to turn all these off just to show you this, because it's pretty cool. Oh, see, I forgot to hit save. You have to hit save after each change So we'll disconnect from the trigBoard, and then just looking right here, there it is. So I'm going to go ahead and close the, so if I open the door, you see contact is opened. I'm going to close the door, contact has closed. So basically the trigBoard here is sending a message to this ESP32, and that's the way that works. So eventually I'm going to build a whole system up here where you can control the whole network. You know, this can be battery backed. You'll have a cellular modem connected over here to the gateway side. So it's like, you know, like my ultimate security system. But let's fire up that configurator again, hold that wake button, and there was our button was pressed there. It even gets sent out. Don't worry about these error messages. That was part of my testing, but you see the front door button was pressed. We'll connect up again. Now I'm going to uncheck UDP and show you the last thing I added in, MQTT support now. So this is kind of cool because you can now tie this into your Raspberry Pi home automation system if you're running your broker over there. And we've got security built in here, so if you wanted to use security, you can with a username and password. I don't have a lot of experience, you know, setting up the Raspberry Pi with this sort of thing, but I did test this out just by installing, I think I installed Mosquito or something, and you do see the messages go across. So this is still something kind of still in development, and eventually I'd like to tie this in with Home Assistant and all of that stuff. So anyway, I put it in there for now so you can experiment with it, and I think that is everything in the configurator. Oh, one last thing. I did not mention what the high-speed trigger is for. So the high-speed trigger is in case you're monitoring something where you've got a contact that could like open and close like that, like really quick, and you want to catch both. The high-speed trigger can catch that, but it's very sensitive. So in the case where you've got a normal door opening, you know, where somebody is kind of opening it, but it might have a little jitter on it, you probably want to keep this unchecked. Or a garage. That's how I actually discovered this issue, because before I only had the high-speed trigger software built in, and it was actually giving me a double tap with the garage, because the garage door kind of shakes when it's going down, you know, and then passes by the magnet. You know, I was getting a double tap on it or a double message out. So now I've got this high-speed trigger option. You can experiment with it too as well. So if you're seeing that, you know, a door opens and closes really quick, like really fast, and you're not seeing both the opening and closing of that door, then you may want to try the high-speed trigger out. And I think eventually I'll get into the details as to how all of this works, but essentially the trigBoard has a lot of circuitry built in to support both the opening and closing detection of this contact. You know, there's a whole latch circuit. I mean, if you just take a look at that board and all the tiny components that are on there, you can start to get an idea as to how complex this board design really was. And, you know, I keep talking about this contact input, but really the trigBoard can do much more. You know, like, we now have that adjustable timer that you can configure, so you could ignore the contact input and wake and check some sensor values that or some kind of sensor you've got hooked up to the expansion pins here, and then send that, you know, to the cloud and then go back to sleep. So you could build like a weather station or, you know, whatever you wanted to monitor at some interval. So anyway, and I'll probably make a video on that as well, but in this video I just wanted to throw everything I could think of with this board. I'm sure I missed a whole bunch of stuff too, but that is a very long introduction to the trigBoard V8. Oh, and I forgot to mention that it supports OTA. And I think I'll make a whole video just on how to program this board. So you can hook up a USB to serial converter to the board just like that. And then now you've got yourself a little ESP32 development board. Or you could OTA it. So right now if I clicked initialize OTA, it's now set up to load that firmware directly from the Arduino IDE if you see that as a server port, or you can do it from the terminal. And I'll show you both ways too in a future video, but I think this one's getting long enough, so I'm going to probably call it there. So by the way, these trigBoards are available in the Tindy store now. I did a small batch run. These boards are made in the USA. Okay, so with all the virus stuff going around at the time of making this video, and when I was doing the first sample run of it, it made sense to build these here, and I think I'm going to continue to as well. The quality of these boards is just amazing, so I think I'm going to stay with the US manufacturer to get these built. So that's kind of another cool thing. So anyway, I've got a small batch run, so when you go to the Tindy store, if you're interested, you are going to see these are pretty expensive, and hopefully I can bring that price down on the next production run, but that might not be for, a couple months. So anyway, if you're interested, go ahead, check them out, and if you got any questions, let me know. Thanks for watching.